Alright, today we're going to talk a little bit more about monomials, and then we're going to actually get into our first two exponent properties and look at a couple of exponent rules when we deal with multiplying some of these monomial terms. Right here on the screen I have three different monomials. We can tell they're monomials because there's only one term. Even though we have a 4x squared and a 3y, there's nothing that's being separated by addition or subtraction. Everything's being multiplied, so we have one term here. But these are three different types of monomial expressions. The first one right here, negative 38, is just considered a constant. This is a review of what we talked about today in class, so hopefully this is pretty fresh in your all's memories. The 4x squared here, because x is being squared, what type of expression is this? Hopefully you were able to come up with a non-linear expression. And then the last one, this 3y, still a monomial, but it is linear. A linear monomial expression. So you might be asking yourself, okay, all three of these are monomials. What's an example of something that's not a monomial? And anything like, well, 3x to the fourth minus 5y. This is actually a binomial. We'll talk about that a little bit more next week because we have two terms. We have the 3x to the fourth and a negative 5y or a minus 5y, so two different terms. Monomials, though, are these three here that we're looking at. Moving on, we want to talk a little bit more about exponents. And on this screen now you can see this x to the fifth. Well, I have this up here so we can kind of identify some parts of an exponential expression. This is a monomial, as you guys know, and it's also a nonlinear because the exponent on it is 5. But one thing we need to look at here is classifying this. This x is considered the base, which is known as the base of the exponential term, and then the 5 is the power. And it's what the base is raised to. This tells us x to the fifth is equivalent, x to the fifth is equal to x multiplied to itself 5 times. 1, 2, 3, 4, and 5. The base tells us what number or what term, in this case a variable, we're going to multiply, and then the number up here tells us how many times to multiply it to itself. So it's x to the fifth, 5 factors of x. The first rule that we're going to look at today, multiplying exponential expressions, is called the product of powers. So now what we're saying is, okay, what happens if we have this exponential expression, x to the fifth, and we're multiplying it by another monomial exponential, x to the fourth. So we have 5 factors of x, and we're multiplying it to another term that has 4 factors of x. The question is, how many combined factors do we have? So there's a couple of ways to look at this. If we remember, x to the fifth, as we saw up here, is really 5 factors of x. So we could have x times x times x times x times x. That's what x to the fifth here becomes. So then you can also go with that x to the fourth has 4 factors of x. So we'd have x times x times x times x. 1, 2, 3, 4 for x to the fourth. If we look at the total number of factors, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 factors of x. Remember, a factor is a number or term that is multiplied to another number or term. We have 9 factors of x. Or we can simplify this to x to the ninth. Back to the very original problem, x to the ninth. And this now shows us how to multiply exponential expressions. Hopefully you might see some type of rule here. Okay, moving on to another example. What if we had something like 3x to the sixth times 4x to the second? Well, if we remember, everything here is being multiplied. This is a 3x to the 6th. It can be rewritten as 3 times x to the 6th times 4 times x to the second, or x squared there. So now that we can see everything is multiplying because of our commutative property of multiplication, we can rearrange the order. This is the same thing as 3 times 4. I'm just putting my two integers together, or my constant terms, times x to the 6, which we still had here, times x squared, just reorganizing them to make the multiplication a little bit simpler. So now we have 3 times 4, everybody can do that, is 12, and x to the 6 times x to the second. Be careful, this is not x to the 12th. X to the 6 times x to the second actually becomes x to the 8th, because again it tells us how many factors of x do we have. We have 6 here, we have 2 here. We can add those powers together to become 12x to the 8th as our final answer. Alright, moving on. And remember, if you ever need to pause or rewind, you can always go back and take a look at the previous example. The next two are going to deal with raising an exponential expression to another power. So the rule that we're going with here and that we're looking at is called power of a power. We've got two different examples, and hopefully we'll be able to come up with a general conclusion. So we have x squared raised to the third. So now this x is actually the base of this x squared, but then x squared is the base of this whole thing that's being raised to the third. So what I like to do, if I'm not sure how to begin, is just expand it out, because we know what it means to raise something to the third power. It means you take this base and multiply it to itself 3 times. So to raise x squared to the third, it'd be x squared times x squared times x squared. We have 3 factors of x squared. 1, 2, 3. And now, to break down this, we know it's x squared times itself times itself. Well, x squared times x squared, we add these two from our previous rule that we were just looking at. Product of a powers tells us that we add them. That becomes x to the 4th times x squared, this last one here, and that finally becomes x to the 6th. And yes, you can kind of cut a step out here if you just go 2 plus 2 plus 2 to give us that final answer of x to the 6th. I'm going to let you do this one on your own. It's y to the 4th all to the 13th. Y to the 4th to the 13th. Take a few seconds to try to solve this one. Okay, instead of expanding this one and writing y to the 4th 13 different times, hopefully you used the trick that you might have noticed from this one before. If we had x squared to the 3rd, if you multiply these two exponents, that will give you the final exponent here. So if you look at 4 and 13 and find the product of 4 and 13, which happens to be 52, that gives us our final exponent that we would raise this to. Becomes y to the 52nd. All right, we're going to look at one final example today that's a little bit more challenging, but I think it's one that you're up for. We have 3x squared times the quantity of 4x to the 3rd, close parentheses, all squared. Anytime I look at a problem like this and I see two different terms, but one of them has parentheses, I'm going to start with that one that has parentheses and try to simplify that down more. So we can't forget about this 3x squared because it's still part of the problem, but I'm just going to kind of keep that out in front and put that off until a later step. What I want to look at is this 4x cubed and squared, how it is raised to the 2nd power. Well, again, anything that's raised to the 2nd means you take that expression, that entire term, 4x cubed, and multiply it to itself. So this 3x squared gets multiplied to 4x cubed times 4x cubed. Okay, there were two factors of 4x cubed. So now moving forward from here, I'm going to keep this 3x squared out in front, and then we can look at this 4x cubed. This becomes 4 times 4, the two factors of 4, and then we have the two factors of x cubed and x cubed. Even more simplified, the 3x squared, 4 times 4 gives us 16, and x cubed times x cubed is not x to the 9th. It's x to the 6th. We add the factors. Now we're one step or so away. The 3 we can multiply to the 16, or if we'd rather look at it this way, it'd be 3 times 16. We still have an x squared, and we still have a factor of x to the 6th. 3 times 16 is 48. And x squared times x to the 6th is not to the 12th, it's x to the 8th, excuse me. So we have 48 x to the 8th as our final answer. Hopefully you were able to get these 5 examples down, and if you have some questions, re-watch some parts of the video. I know it was a little lengthy today, but if you can re-watch some examples, that might help. But make sure you come to class tomorrow prepared with some certain questions to ask. Have a great evening, and I look forward to seeing you guys tomorrow. Thanks.